Hello everyone, welcome to this presentation on heat and temperature. In this video, we will understand the core ideas of heat, temperature and thermal equilibrium. Let's talk about heat. Heat is a form of energy. At microscopic level, all molecules and atoms in a system are in constant random motion. This motion depends on internal energy present in a system. In general, this motion can be of different types: vibrational, translational, and rotational. These microscopic motions together define the macroscopic energetic behavior of a system, which we often relate to heat. However, there is an important distinction. If there is no transfer of energy due to temperature difference, we do not call it heat. It is simply internal energy within the system. In simple terms, heat is energy in transit, flowing because of the temperature gradient. We can understand heat better through some everyday example. First, when you leave a cup of hot tea on table, heat flows from hot tea to cooler surroundings. Second, when you touch a hot pan, heat flows from pan to your hand, which is why it feels hot and can even burn you. Third, when ice is placed in warm water, heat flows from water to ice, causing it to melt, and heat from the sun reaches to earth through radiation, warming its surface. Now this brings us to an important question: what is temperature? Temperature is a scalar quantity that tells us the degree of hotness or coldness of the system. In simple terms, it gives a numerical measure related to the energy of the system. It is a measurable macroscopic property and is directly related to the average kinetic energy of the particles in the system. We can understand temperature through some example as well. For instance, the normal human body temperature is around 37 degrees Celsius, which reflects the average internal energy of the body. Similarly, when we say a day is hot or cold, we are referring to a temperature of the environment, not necessarily the total heat energy present. Here is interesting relationship between heat and temperature. We do not actually feel temperature directly. What we feel is the transfer of heat between our body and an object. That is why two objects at the same temperature can feel different when touched. For example, metal feels colder than wood, even if both are at the same temperature, because metal removes heat from our skin more quickly. So our sensation depends on the rate of heat flow, not just temperature. Temperature is measured using a thermometer, and this measurement is based on concept of thermal equilibrium. Heat and temperature are closely related, but they are not the same. Temperature tells us how hot or cold a body is, while heat is energy that flows due to a temperature difference. Now the question arises, what is exactly thermal equilibrium? Whenever two bodies are at the different temperatures, heat flow from hotter body to the colder one. This process continues until both bodies reach the same temperature. At this point, the system is said to be in thermal equilibrium. Even though microscopic energy exchanges may still occur, there is no observable heat transfer at macroscopic level. It is also important to note that two objects at the same temperature can contain different amounts of heat depending on their mass and the material they are made of. Thermal equilibrium is a fundamental concept in thermodynamics and forms the basis of the temperature measurement. A thermometer works by coming into thermal equilibrium with the object being measured. Only after this equilibrium is reached, it shows the correct temperature. This idea is closely related to the zeroth law of thermodynamics. Zeroth law states that if two bodies are each in thermal equilibrium with the third body, they are also in thermal equilibrium with each other. This law provides the foundation for defining the temperature and ensures the consistency in how we measure it. And that is the core idea of heat, temperature, and thermal equilibrium. Thank you for watching.